All right, in this video, I'm going to go over finding the slope-intercept form of a equation of a line when all you're given is 2 points. Now, if you've reviewed the previous 3 videos that I've made, you should be able to figure out, okay, well, what can I do with just 2 points? Well, we can find the slope, right? Now, if you don't remember what the equation is for finding the slope, just remember that slope is rise over run, right? Well, we know we're talking about the Cartesian coordinate plane. The rise is the y-axis, right? So you could also say it's the y's over run. And the run is the x's, so it's the y's over the x's. Okay, that's how I remember it. And if it's the y's over the x's, what do we do with them? Well, we kind of subtract them. So what are our y values? 7 and -2, right? 7 minus -2. Yes, I put parentheses around that because it's always a minus there. The -2 is important. Now, since I used the 7 as the first number, I need to use the 4 as the first number here. If you use -1, that would mess it up because you got to use this same point subtracting the other point. You could go the other way. You could take this point and subtract this point like this. But what matters is 4, 7, -1, -2. Those have to be on top of each other. 4, 7, -1, -2. Just got to remember that. It doesn't matter which point comes first. Just use this one because it is first. Going left to right. But now we actually subtract that out. So we have double negatives, right? So 7 plus 2 is 9, and 4 plus 1 is 5. So our slope is 9/5. Okay, that's part of the battle because we're trying to get a slope-intercept form, right? Which is y equals mx plus b. Well, we have the m part. All we're missing is the b part. So we got that. Check. How do we get the b part? Point slope. We use the point slope formula, which is y minus y2 equals m times the quantity x minus x2. Or x1, actually. x1 and y1. Now we have that slope, so that part's done. Which point do we use for x1 and y1? Doesn't matter, either one works. Let's do this one just because there's no negatives to throw us off. So 4, 7. 4 is the x, right? 7 is the y. Gotta keep that straight in your mind as well. Let's distribute the 9/5. So y minus 7 equals 9/5 times x minus, it's 9 times 4, 36 over 5. Things don't always work out nicely. Sometimes you get fractions. Add 7 to both sides. Interesting. We can't just add 7 to it. We got to get a common denominator, right? Right now it's just a 1. So we need to multiply this number by 5 over 5, which is just 1, right? So we get the same number. 7 times 5 is 35 over 5. So we're actually adding negative 36 over 5 plus 35 over 5. Negative 36 plus 35 is not 9/5. Just rewriting that down there. Negative 36 plus 35 is negative 1. And there's your answer. Negative 1/5. So our answer is y equals 9/5 x minus 1/5. Now, I'm going to erase this, all of this, and prove that I can get that same answer using the other point. Same formula, different point. Y minus negative 2, that's the y value, equals 9/5 times x minus negative 1. That's a better way to write parentheses. If you have a parentheses inside of another parentheses, you use brackets for the outer parentheses. But anyway, doesn't really matter as long as you can keep them straight. Y plus 2 equals 9/5 x. I'm distributing now. Plus 9/5. Okay. 9/5 times 1, yeah, 9/5. That was easy. Subtract 2 from both sides. Y equals 9/5 x plus 9/5. Okay, 2 over 1 in fifths denominations is negative 2 times 5 is negative 10 over 5. Minus 10/5 is, guess what? 9 minus 10 is negative 1/5. So we got the same answer using the other point. Also a good way to check your answer. All right, thanks for watching.